Hey guys, in this tutorial I'm going to try doing something a little bit different. We're going to do a topic-based modeling exercise where I'm going to show you guys how to model a motorcycle tire like this one. So there's a couple of things that make this motorcycle tire special, and one of them is that it's actually parametric. Let me give you a sneak peek at what I mean. The tire is actually created using a bend deformer, and you can basically unwrap the tire and wrap it back up. So we're going to go over the calculations necessary to get that bend deformer to play ball. We're also going to look at how you can achieve some pretty stunning surface topology using this technique. Now we're not going to create a tire looking like this one. We're going to create a tire for the Razorback bike model that I've been working on, because right now I just have some low polygon proxy objects for the tires. Instead of doing this tutorial as part of the Razorback series, I'm breaking it out so it can be used on its own. The first thing I did was copied this sort of low polygon proxy object into a new file. So if I go to my file here, I can see that I just have this front tire. It's made of a lathe NURBS object with a simple spline as the profile, and it does the job if you have a motorcycle that's going to be seen from this far away, or if you're going to be using texture maps for the treads on the tire. Now for the Razorback, I wanted to create sort of dual sport treads for the tires, so I'm not certain this would be the right type of tire for this type of bike, but I think it might be. And this is some reference material that I found. You can see that it's a really chunky design of tire, and it's not quite like a motocross tire, but it's not quite slick and smooth like a sport bike tire. It's somewhere in between, and I think that's the characteristic we want for the Razorback. Now, we know that motorcycle tires are tricky to model because they curve in 2 dimensions at once. In the real world, when they make one, they just create a mold and then they start injecting it, and as long as the mold is perfect, the rubber flows into all of the cavities and it's fine. But in 3D, we need to come up with some clever methods to achieve similar results. So we're going to be looking at how to do that. Here's how we start. The most important thing is that your center point of your tire is pretty well defined, because we're going to be using that a little bit. The next thing is the process. So you saw me unwrap that other tire in the other file, and it sort of gives you a hint as to how we're going to do this. We're going to take a straight piece of tire and wrap it around in a circle. So what we need first is that straight piece of tire. So to create that, let's create a plane. I'm going to leave it as a editable object for now, but I am going to reduce the number of segments to maybe 10 by 10. From the top view, I'm going to scale it down until it's roughly the same width as the tire. And now we can see that the plane is centered with the tire, so it shares the same coordinates. But what we're going to do now is we're going to push it up to the outside surface of the tire. So imagine we wanted to wrap a untreaded tire with wrapping paper. And this is how we'd start. We'd start with one square of paper and we'd put it right on the surface of it. So once we've got that in place, we're a lot closer to the end result. But if we're going to stretch this piece of tread all the way around, we're either going to need to make it a lot longer, like this, or we're going to need to have more than one, sort of a replicated sequence of them. Now, because tires have repeating geometry, a replicated sequence seems like the right choice. So focusing on the front tire right here, we're going to just look at a section of tire right there, and we see that maybe we can create it using sort of an offset principle. So you can see here that we can sort of draw a chevron shape and it kind of works. So that's going to be a little tricky, but we'll try it anyway. But the main thing to remember is that the sliver of tire we're dealing with here is quite small. So we're thinking maybe it'll be quite squat, something like that. And we can adjust the number of segments in the plane accordingly so that it looks a little more uniform. Okay. So the next step is to try to figure out a little bit of math. I was never one for math in high school, but the math we're going to be using here is basically circle math. So the circumference, diameter, we're going to be dealing with pi a little bit. What we need is we need a bend deformer. All right, it starts off with just a big box. So we're going to scale that down and move it up to the top here. Now, when we increase the bend strength of this bend deformer, it bends towards us right now. So we can rotate the bend deformer, or we can change the angle here. So let's change the angle to 90 degrees. And we can also rotate the bend deformer like this, so that it starts at sort of the 12 o'clock position where we are. Seems to work so far. Now we're going to want this bend deformer to go 360 degrees, like this. But now it gets kind of tricky, because the center point of the bend deformer is all the way over here. We sort of want the bend deformer to have its center point here, and it seems like a really tricky thing to measure. I mean, measuring it is one thing, but it needs to be perfect for what we're doing here. So that's where the math comes in. If we reduce the bend amount, just so it's just a little bit, and we can sort of look at the coordinates a little bit better, we have the y length, we have the x, or the width, and we have the z, the depth. So for this example, we're going to be using the deformer in the unlimited mode. So it doesn't really matter how big and chunky it is, but it helps to visualize it. So we're going to do a sliver like this. Let's use round numbers. So 1.5 for the thickness. Let's go to the top view. It looks like I moved it. Let's make sure it's still at the center of the scene. And for the width, let's make sure it encompasses most of the tire. Again, it's just for proportion. And then here's the tricky one, the length. Like, how long does it need to be? If we know it's going to be 360 degrees around, we know it has to be pretty long, but it gets so difficult to position it at this point. So here's how we do it. Let me just go to the side view, so maybe I can sketch it out a little bit better. We have two dimensions that we can work with right now. We have the radius of the tire, and we have the center point, which means we have this dimension, and then we have the circumference. So we actually have enough to figure out where to position this bend deformer. Let me show you what I mean. The position of the deformer in this view, so the YZ, the Y position is really easy to figure out. It just needs to be the same as that first segment of tire that we created up here. So this plane is currently at 11.593 inches. So that means that the bend deformer needs to be at that same height. The reason is we kind of want it to start like that, up here on the surface. So what we can do is we can set the Y position to the same value, 11.593. I just pasted it in. The next thing we need to figure out is how long is that circle, how long does it need to be to fit our tire perfectly? So to figure that out, we can apply pi to the diameter of this circle. So we know the radius of the circle, 11.593, from the center to the edge. So the diameter is 11.593 times 2. And if my math doesn't fail me, I believe the circumference, in other words, the y length, should be 11.593 times 2 times pi. So let's see what that gives us. I hope I'm right here. So 11.593 times 2 gives us 23.186. And if we then just say multiplied by 3.14159, it gives us this big circle. So I think that value looks correct. So what we've done is we've actually made it so it's the right size. Now it doesn't look like it's the right size, but if we go from the side view, we can see that that's actually because of this keep y-axis length option. When this is turned off, it sort of bends on the outside of itself. When you turn this on, it bends more on the center point. So we can see that we've actually gotten the circumference to be perfect. Now we've kind of gotten the y or z positioning here, but we can get that exact as well. If we unwrap the bend deformer, we can see that laid out straight, it's going to be just the circumference. So that means that if the circumference is 72.841 units, and this is the center of the scene, then it probably needs to be half of 72.841, and it'll be the right distance away. So if we set it back to 360 degrees of bend, and then we set this is the Z position, you can see the Z position moving down there. The Z position is going to be 72.841 divided by 2. And that gives us the perfect positioning for the bend deformer. So now we can take this object, duplicate it around the tire, and be confident that it's going to be bent at the perfect angle. So the next step is going to be duplicating this plane forward. Now, it seems like a good job for a MoGraph cloner, so let's use that. Under the MoGraph menu, I'm just going to grab a cloner. Now by default, the cloner starts cloning objects from its center. So if we put the plane into the cloner, we see that the cloner has started down here at the bottom, and it started to clone this object upwards. Not really what we want. So I'm going to ungroup that, and the plane is up here at 11.593 inches. So I'm going to move the cloner up to the exact same location. Now the clones go upwards from there, but we don't want them to go up. We want our clones to go forward on the z-axis, not on the y. So we can enter 0 for the value on the y. And for the value on the z, we need to calculate this pretty carefully. But before we do that, let's just do it roughly. So it looks like we can do roughly 1.488 inches. And then in the cloner, we can just increase the number of clones. So let's see roughly how many we need. If we create a null object and place the cloner in there along with the bend, it's going to influence it. So now we can see our cloner is bending along the wheel, the tire, and we can sort of increase the number of clones until we're almost at the other end. And this is where we can start to play with the values a little bit. So there's two ways to do this. One way is just sort of interactively playing with it until it lines up. The other way is by actually calculating the length of each clone and the number of clones required. I'm just going to do it the easy way. So the easy way is you take the plane, and we know how big it is on this dimension. Let's set it to 1.6. And so we know the cloner needs to be 1.6 units until the next clone. And that gives us the right spacing. But there is a little bit of overlapping happening here. The clones are coming right back around and hitting themselves again. So to fix that, the easiest thing to do is just to grab the cloner, which has an origin of right here, and just scale it. So as we scale it down, we can see that it basically changes the length and the width, but more importantly the length. Now what we're going to do is we're going to get it as close as possible, and then we're going to go down to the size here and start tweaking the size. So we can go 0.4, got a little bit closer, let's try 0.84. It looks like it's almost there. Let's go 0.83. Yeah, so it looks like 0.84 gets us right up against the edge of it. And we're still not perfectly lined up. There's a little bit of a gap, but that's okay because we have gaps everywhere. Each one of these objects is not joined to its neighbor yet. Let's see how we can actually do that. If we go here to where we know there's a gap, we can actually see it. Let me change my view clipping to small so we can zoom in some more. We can actually see the gap. The way we fix this is with a connect object. So you've seen me use the connect object before. I'm just going to say connect, and I'm going to drop this null object in there. So right there, it's sort of merged all of these objects into one. So we can see that the object underneath is poking through a little bit. Let's just hide it for now. So what we have now is we basically have a parametric ribbon. We have an object that goes right around, and it doesn't have any seams or any gaps in it. The Phong shading should be perfect all the way around it because all the objects are joined. I think if we turn off the connect object, you might be able to see. It might be difficult to see with the video compression, but there are steps. You can see each object. But once we turn on the connect object, it becomes one continuous strip. So we've basically created a parametric tube, and you're probably wondering why all the trouble, because Cinema 4D comes with these built in. It's just a cylinder. But we can do something with this that we can't do with a cylinder, which is that we can sort of tweak the number of segments we need. And I'm just going to create something uniform looking. And if I were to convert this to an editable object, an editable plane, we can see now that we can sort of select patterns in here and extrude it. And it extrudes all of them at once. And so this is getting us well on our way to creating a spherical city, a cylindrical city, or a motorcycle tire. So now might be a good time to look at the reference material. I'm just going to undo a little bit. And if we look right here, we can see that for the front tire, which is the one we're working on, we can sort of see that there's a chevron shape, but it's sort of an offset chevron shape. Let me see if I can illustrate what I'm trying to show. It's not simply a pointy thing. It's a pointy thing like that. But the repeating pattern we have should be able to handle that. So let's start off by trying to create that shape. If I go to the top view, turn off the bend, turn off the cloner, we're left with just a plane. We should actually be able to warp this object into that shape. So I'm just going to use a freeform deformer because I think it'll do this a little bit more quickly than if I did it by hand. So I'm just going to scale my freeform deformer until it's basically the size it needs to be. And I'm going to place it as a child of the plane. And then I can grab these points on the edge. And nothing. It's probably not lined up in the view. So I'm going to place it over the object. And this time when I use my rectangular selection, I'm going to make sure it's selecting all visible elements. And we scale it down. It looks like it's sort of bending it. Let's try more segments. So let's do... You know what, this is probably just going to be easier to do by hand. Let me do it by hand. So what we want is we want the plane to have enough subdivisions so that we have one in the center, so an even number. And I'm trying to strike a balance between not too many segments and not too few, because we are converting it to an editable object at this point. So we just press C, and then, whoops, 14. So we press C, and then what we can do is we can sort of, let's see, let's grab these 2 rows of points, sweep them back. Let's take all the rest, sweep them back as well. And you can kind of see what I'm doing. I'm just sort of creating this chevron shape. But at a certain point, I think one side of the chevron needs to go further back than the other. So I'm just trying to figure out what it would look like. So with one side going a little further back than the other, and this side still needs to sweep back, just not as far. And we can sort of see what's happening with our cloner. Our cloner is replicating that quite nicely. Because notice that if I were to move these points forward, it moves forward on all of them. So it just sort of stays with it. It's a really nice effect. And so now that we have this chevron sort of shape, let's go back here. So it looks like we want this part of the chevron to come all the way up and hit the edge, and this other part starts kind of late. And I'm trying to figure out, it looks like it does that for the entire duration of the tire, or does it actually have something here that I'm not seeing? I think this shape is playing tricks on my eyes, but let's just see how it works out. Okay, so it wants these polygons to come all the way up and hit there. So that's not going to work with the pattern that I have right here, so we'll just improvise and do a similar looking pattern. So I think what we need is we need something like that. In terms of our mesh. I'm not immediately certain how to create that. So we'll just do something similar looking. This is really bugging me though. So moving on. We can bend this object around, and then we can do the extrusion. So let's do that. Sort of trying to figure out what it's going to look like. So we can do a block of stuff there, and then another block down there. Or let's try this. I think I have an idea. What if we were to select all these faces in this plane and use the clone command to make one clone and then move that forward. So we now have twice the area, and that's going to mean that we need half as many clones, so we're only going to need 24 to cover the same area. And I'm just going to turn the cloner off. Let's sort of select the loop of edges here. This one and that one, and then deselect all the other edges. I'm just going to use the Stitch and Sew tool to patch this back up. It's usually a lot of trial and error when creating a tire like this, at least in my experience. So we can do MP to get the stitch and sew, and then we just stitch those edges together. Now we do have a different offset for our cloner. Notice even though I have half as many clones, it's not going all the way around. It's because the clones aren't the right distance apart. But if I were to select this, it'll give us the length of it, which is 3.046. That's the size, and hopefully if I enter that, it gives us the correct distance. Not quite, but we can just scale it down to fix it. So I'm just going to scale down the cloner a little bit, and then we get this double line right there, and we can go back to the size of the cloner, so 0.13, 0.11, 10, 75.9, 0.8. No, that's not right. Looks like something might be doubling up. No, I think we got it. Let's turn off the connect object, making things confusing looking. So we grab our cloner, we just want to change the size. So 74.9. See 75.5. I think our increment is too big. So 75.45. Right there, we're almost there. 75.075. 077, 078. Okay, that's close enough. We turn on the connect object, and it just sort of fixes it for us. Okay, so the whole point of that is that now we have more material to play with when creating these treads. So what we can do is create one row of tread that looks like that, and the other row will come in down here making the opposite pattern, and hopefully it looks good. So I'm going to start off with this bit selected right here, and what I'd like to do is an extrude inner. So with these polygons selected, I can just do an extrude inner, and remember that this distance right here is going to be half of the gap between the treads. So it's actually a pretty big gap on this tire. So let's make sure we have a nice big gap. Okay, and looks like these edges are still a little bit wobbly, so I can probably come in here and just make sure those are nice and straight. Just make sure to select all the points and move them as a single unit, because if you don't, it won't line up correctly any longer. Okay, so I'm just going to do extrude inner, apply, we get that. Now I just need to do the other parts. So I'm going to select these polygons, are going to be another big chunk, extrude inner, apply, and then I'm going to select the opposite down here. So it looks like I went over 2 units. 1, 2, and then I can do extrude inner again, apply, and right here select this last group of polygons, and one more time do the extrude inner. So what we have now is 4 groups of polygons that we can select and sort of extrude. The easiest way to select these might be with a loop selection. So we can select the gutters in between, and then we just invert the selection, and we got all of our islands that we created. So now that we have these islands created, we can turn our bend and our cloner and our connect object back on. You see we have a lot more geometry now. And we can just do an extrude operation. So just to see how much, we need to extrude it quite a bit. So you can just drag that up. And we get our nice thick looking tread. With this sort of chevron shape. It's not quite the same pattern we had here, but I'm sure we can achieve that if you just spend enough time creating the sort of prototype shape for the tread using sort of a wireframe mesh like this. And so once this part is created, you can just start to go nuts beveling it and smoothing it out and stuff. One place you're probably going to want to bevel it is down here in the sort of canyons that it's created. I'm just going to select the loop of edges around each of these. So it looks like it's all 4. And then just using a simple bevel, just going to do the bevel operation. Now remember not to bevel too far, because otherwise the connect object is going to merge the points in an undesirable way. But you can fix that by just reducing the tolerance of this. So I reduced it to 0.29, 0.19. It looks like 0.19 is small enough that it doesn't affect our bevel. And we can then do the same thing with the top of the tire. So just like that. And we can even come in here and do the central spine down here. So that would involve a loop selection, maybe a greedy search will do it. Not quite. Might have to just select it in the top view. So we can just select all those edges that run down the middle. And then we can bevel it to get a nice rounded part on the front there. And you can go through and add polish to whatever aspects of this tread pattern you want. Even go as far as using the brush tool and part of it. So now that we have the tread pattern, there's still a couple other things to do. Let's turn back on the front tire proxy, and immediately we can see, well, it's just straight across, but that's not what a motorcycle tire is like. It curves down at the sides. It's pretty easy to fix. So I'm just going to call this 360 bend, and we're going to create another bend deformer. I'm going to go from the front view and scale this deformer down a bit. Now, if we increase the strength on this deformer, let's say 45 degrees, we can see that if we rotate it like this, 90 degrees, it's sort of starting to look correct. And we can just sort of scale it down, just kind of looking at it, and you can see it's almost near the center there. Now, to make it perfectly at the center, I think we can use the same trick, where we take its dimension, and then we make that its x position divided by 2. So it's perfectly on the center right there. And if we wanted to maintain it perfectly on the center, what we could do is we could group it, ungroup it, so we have a null at the exact spot where it is, and then 0 on the x-axis, and put the bend back into it, and then we can just scale from the null object, and it's scaling using that coordinate system. So I'm going to move the bend deformer down to right there, right on the surface of the tire. And we're going to change its x dimension, just so it's a little bit more representative of what it's doing. And we can then take this bend deformer. I wonder if it'd work with the null as well. No, we need to ungroup it for it to actually work, but I'm going to leave the null object in the hierarchy. So now we take our bend deformer and we can see that if we increase the strength, we get the tire to curve downwards. Now we can make it curve the other side by choosing unlimited as the mode. So it curves both sides now. And we can sort of see how it needs to curve. Now, this is one of those cases where we don't want to choose keep y-axis length, because we actually do want it to sort of stretch the tire around the edges. Now, even though we're doing our best to stretch it, it's not really representative. Like look at how far the bend deformer is curling for these tires. So what I'm going to do is I'm going to put the bend deformer back into the null and scale it down a little bit so it's closer to the edge of the tire right there. Let's see how that does. Okay, so that's a much better representation of how the bend is working. And even though we bent it all the way down and it's being stretched on the edge and everything, it still isn't going down far enough right here. And to fix that, we can just scale the source object. So we can take this object and scale it on the x-axis. We can safely do that without messing up the cloner. And we just scale it until it goes down to the right amount. Like right there. And then we can go to our bend deformer again. And we can just make sure that's bending the right amount. And there we go. We have like our curved profile of our motorcycle tire. So when we look at it just sort of in an isolated view, I mean, it's not the most attractive looking tread pattern because we didn't spend a whole lot of time on that. But the idea is that you can make this segment of the tire whatever you want. Like for instance, let's make this tread pattern a little more interesting by smearing it around a little bit. So I think this should work. I hope it works. As long as we keep the boundary of the shape intact, we should be able to smear the inside of it to get a little creative flair. So I'm going to use a lasso selection. Maybe there's a more efficient way to select. Let's do a loop selection around the edge. No, because it's just gonna, well, maybe we can do this. Thinking out loud now. If I select all of the loops, we may be able to come in here and deselect the inside part of these loops. Like that. And then use the fill selection tool to select the inside. There we go. So this sort of guarantees that we're not going to tamper with the edges. We can even go a little bit further by just deselecting some of these near the edge, so we can be pretty sure we're not going to mess with them. And what we can do from here is use the brush tool to sort of smear things around. So if I use the brush tool, a smaller radius, and we use the smear mode, see we can sort of smear the treads around, sort of give it more of a stylized look. And it does sort of make it a little more interesting. But I just wanted to give you the idea. The best way to handle this is to do what I did on this wheel, which is to actually take the time to sketch out the first piece. You can see here that I did not use a cloner. I used instances. You can do that too. But you can see here I really took care to make sure that I was really getting the right pattern here. This is a pretty complicated pattern, but it does repeat. You can see right up here where it ends, it picks right back up. And it looks really complicated here, but think about this with just square grooves, because that's how it started off. And then of course I did the and then I beveled the edges and did the hypernerbs and all that other stuff. And it also shows how you can bring the edges down like this. So let's do that in the other file. So just to make this look a little bit better, let's go back to when we had the top parts selected, the tops of the islands. I'm just gonna do the old extrude inner trick. So this Phong shading is looking really smooth and kind of weird. So if we have all the tops of the islands selected and we just did an extrude inner, you can see kind of makes it a bit better, even though something weird is happening here. Okay, let's just do a little extrude inner and then a normal scale. Maybe that'll work. Yeah, there we go. So I can take my time and do this better. I'm just trying not to make the screencast longer than it needs to be. So we have sort of this shape of these treads going right to the edge, and the tread coming up in the front and center and curving. I mean, you could put this in a hypernerbs after if you want, but as you can see, it's pretty smooth, nice and curved on both dimensions. So getting the side walls is super easy. All you do is, using the rectangular selection tool, you just select the edges on both far sides. Once you have those edges, you can use the scale tool or any sort of extrusion tool to bring those edges out like that. And you can see as I do that, it's sort of bringing them down over there on the side of the tire. So the reason it's coming out at a strange angle like that is because it is being bent. So I'm just going to bring it down like this, and then I'm going to scale again to get sort of the majority of the side wall. And once I have this side wall part, I can just move it down and it sucks in. So if I put the front tire proxy back in place, we sort of have something to gauge against. And you can see here that I'm sort of bringing it in and out. I'm going to turn on wireframe mode so we can see. And you basically have two controls at this point. You can scale them in and out, or you can move them up and down. And each of them kind of do the same thing because, again, you're bending the side of the tire down. So you have to take that into account. The other thing we can do is subdivide these walls once they're sort of the correct size here. As you can see, I have them at sort of the correct size. The reason is because most motorcycle tires have a slight concave or convex shape right here. So we can just use the knife tool. If you tap and release shift, it sticks. And you can actually set that to whatever percent you want, like 50%. Then you click and it cuts it. So we can just do that on both sides. Tap shift and release. Set that to 50% and then click. And then we can select these two loops of edges and we can scale those. And that sort of creates either a concave or a convex look right there to sort of match what we originally had with this tire. So if I completely turn off our reference tire, you can see here that our new tire is sort of a I'm just trying to, there we go, display is shaded. Our new tire has this sidewall, it has these curved treads, and you know, we can really easily adjust those if we needed to. You can also come in here and do things like soften the edge. So let's see, if I wanted to turn off all these generators, and if I just wanted to look at my segment of tire by itself, I can use the live selection tool to select just these points along the edge. Let's do it right here as well. I'm only gonna do it to, why be lazy? It's a long video already. I'll do it to both sides. So then I can just take my brush tool in smooth mode, maybe at 2%, and sort of start to smooth these edges out. Now if I wanted to do this to both sides at the same time, what I would do is select the points on the other side as well. So go back to my live selection tool and just run along the edge here, selecting these points. And this is kind of a hack, but it works, is to make your brush really big. So I'm going to use the brush tool, maybe increase the percent to 10, but the radius, let's make that 50,000. And what happens is you no longer see the radius of the brush because it's huge, but if you click here in the center, you pretty much affect both sides at the same time. You can probably see how that works. So if I turn all the generators back on, you can see that happening in real time. And you can sort of just see the edge of the tire getting a little bit smoother. And that's one way to do it. The edge of the tire comes down a lot more smoothly now. And if we wanted to make that more drastic, we can just grow the selection and repeat the operation. But in general, that's how you parametrically make a tire like this. For the Razorback bike, I'm probably going to remodel this tire with some tread that more closely matches this, because I really like how these Metzler tires look. And yeah, I hope you guys enjoyed this video. It's a little bit different than the ones I normally do. It's not really like a random 5-minute tip on its own, and it's sort of related to a project and a specific task. But I really hope that you guys enjoyed this. If you did enjoy it, let me know. If you want to see more stuff like this, I'd love to know. If it was a little too long and boring and I should probably stick to the other stuff, I'd be interested in knowing that too. So, until next time, see you.